Alright, guys. So, as the home host for this session, I'm left with the hard mission of introducing a guy who is beyond any introduction. So, it won't be, yeah. Uh, so, Axel, I think there is no word to.
Except good luck, maybe. Yeah.
Good luck. Yep.
Thank you, Yunus. I mean, yes, I'm probably not yet at the level of Jeff, but hopefully in a couple of years, maybe close to that I don't get any introduction at all, or can just say my name. So this talk is about the art of the cache. And first of all, we should maybe ask why I talk about caches at all. I could do a survey in this room, but I would suggest that everyone wants performance in alfresco. Doesn't matter if you have a large system or a small system, if you're just handling a couple of thousand files, or a couple of million or tens of millions of files. End users want performance, administrators want performance. And caches are an important part in that goal in achieving proper performance of an alfresco system, apart from database maintenance, other support tools like ping on a network for database connections. Unfortunately for caches, as with other details of alfresco technical architecture, there's only a limited amount of documentation available. Yes, we have our configuration properties defined in docs alfresco, and we have some tuning guides, but they are not usually something that is explained in detail what they are affecting. They're just saying, okay, if you have this problem, increase this value maybe. So there's not really a definition of what's going on under the covers that makes this value take effect or how it affects the system. And art, in the term of the title of this session, I would define as art is the proper understanding of the cache mechanism in alfresco and applying it to effect for improving the performance of the system. As I said in the abstract of this talk, I'm going to be focusing on two types of caching. One focus will be on repository caching and will actually be the majority of this talk because it's the more intimate of the alfresco caches and affects everyone using alfresco. People who are not using Solr, because maybe they can do everything with transaction metadata queries, don't care about Solr caches. So the focus is on repository caching. Luckily, this is one of the few slides that I managed to illustrate in some way. Usually my slides are very technical, but if you look at repository caching, we see that it's a multi-layered caching. We have caching on service layers, potentially also on other layers on top of the service as well. And we have caching on the DAO layer, for example, dealing with node properties, node aspects, stuff like this. It's also multi-layered in a horizontal layer that we have a transactional cache and a shared cache for global data that can be shared across multiple transactions as well. And we have different kinds of caching, different kinds of caches. So we have transactional shared cache as well as an entity lookup cache with some logic. Technically, all the caches in the repository here are pluggable using standards API that alfresco provides as interfaces. So you can actually use your own cache implementation if you want to, and you can extend feature sets of caches in alfresco if you wanted to do that. For enterprise only, we have also distributed caching as a feature due to the inclusion of the Hazelcast library. So in that regard, we can have data distributed across multiple servers and have a larger data set cached in general than on a single system with the RAM available we have as a heap. A second focus in this talk will be Solr caching. And basically, we have the same situation here. We have a multi-layered caching. So we have high-level caches that try to shortcut a query execution quite early. For example, if the entire query already has been run with the same kind of parameters, or the exact same parameters, an exact same user, then basically the results can be returned immediately without doing any further query at all, including even ACL checking can be cached in that way, or is included in these caching. If the cache in specific in the full detail is not if the query in full detail is not cached yet, then we can go back to low-level caches to improve certain aspects of the query, so that the full query may just be might just take the time that it needs to do the delta query aspects that have not been asked before, for example, for a new property. Problem is, it's probably not easy to understand how the caches in Solr work, especially since we have multi-layered caches that also include some recursion due to subqueries and subqueries and subqueries, the way that the Solr queries are internally structured, and due to the way that the internal alfresco caches work into the general Solr caches. So it's not easy to understand. There's also not a lot of documentation, or not even any documentation at all, how these caches behave, other than the properties you can set. Technically, caches are also pluggable. You could technically provide your own cache implementation, but in the case of Solr, we typically just refer to the default implementations that Solr provides. But there are other aspects of Solr caching that you can customize and can plug in. In terms of art of caching and what is out of scope for this talk, would be other kinds of caching that are involved in Alfresco development to some degree or another. One thing is HTTP caching, which affects, for example, if you write a web script, then in writing that web script you can take care of defining how the response should be cached by browsers, by clients. This is out of scope for this one. Same for shared tier caching or served caching of model objects, for example, dashboard components, dashboard definitions, page definitions that are persisted in the Alfresco repository and cached on a shared tier to improve performance. As well as content caching, which refers to caching binary objects for your documents, so basically the content of your documents in a local drive when the content may be stored in a slow, for example, ROM media or in this remote system like S3, that you could use caching to reduce the amount of data you load from S3 and reduce your cost, for example, because S3 is based on the amount of access that you're doing. So these are out of scope for this talk because we only have 30 minutes. Because we only have 30 minutes, let's not waste any time and go into the details of repository caches. So as I was showing you before, we have a multi-layered setup. And in this multi-layered setup, as I said, we have an abstract API that defines the caching API. And this is the so-called simple cache. This is an interface, and every time you see this, you know you're basically talking to a cache in the real sense of a cache within Alfresco repository. There are potentially other caches, for example, in third-party APIs or internally in Alfresco, but if they are not implementing this interface, I don't consider them to be real caches in the sense of what I'm talking about in this session. We have a couple of base implementations in Alfresco community, so there's a simple in-memory cache, a null cache, which basically just discards everything, and a Google cache-based implementation that is the default. In Enterprise, we have the Hazelcast as an addition, also some facets. The transactional cache is a specific implementation of the simple cache interface, which is basically just responsible to managing transaction local data. So every time that some data is read in a transaction or modified in a transaction, the data will first be stored in that transactional cache, and after the transaction has been completed, it will be propagated to a shared cache, will be made available to other processes as well. So this is a way that transactional isolation is ensured on the caching layer of Alfresco. And the entity lookup cache is a very specific cache implementation. Basically, it's just a facade or a wrapper around both transactional and a simple cache. And it's only relevant for the data access object, data access object layer, whatever, for database interaction to actually outsource or consolidate a lot of typical DAO logic, for example, find by key, find by value, create by key, delete by key, stuff like this. So a lot of logic on the DAO layer is actually externalized into the lookup cache, and you can provide callbacks from your DAO to the cache to say, okay, if you can't handle it internally, then come back to me to do the actual selects, to do the actual delete operations. So your DAO implementation can be pretty simple because all of the logic can be, or most of the logic, can be outsourced to this lookup cache. Caching in a cluster. This is a specific case for Alfresco Enterprise. And actually, we should say it's actually not caching in a cluster. It's a cluster because of caching, because there's no specific clustering functionality from my perspective in Alfresco. It's only that Alfresco has a caching layer that supports remote data, the distributed data management and remote invalidation that Alfresco actually has like functionality. So basically, every cache we can have in Alfresco using the Hazelcast library can either exchange data with other caches on other servers within the Alfresco cluster group, or send asynchronous invalidation messages. So using Hazelcast, we have two modes of operation for caches. One is fully distributed. That means that data is sent and exchanged between all of the members of a cluster. And each server has basically a partition of the entire set of data that is stored in a cache. And can even have backups, a defined number of backups. So if a server falls out of a cluster, the data that it cached is still available on a different server and can be used to move forward without having to reload it from the database. Partition can also be moved in between servers if new servers join, so it can be repartitioned, redistributed across the entire cluster. Problem is with fully distributed, if the data is not cached on the local server, it will do a synchronous lookup, a synchronous call to other cluster members. And if you have high network latency, or if you have, for example, issues with timeout or garbage collection on another server, then these operations can really take a long time, can really affect the performance of a system. So that's why it's important, like Windows 7 supporting Alfresco, that we have really low latencies on the network layer, and also really have our garbage collection, our JVM under control, that there are no timeout issues in these communications. The second mode is the invalidating mode. That means that we only have a local cache. Each server has its own set of data that is being cached, and the only thing that's being exchanged are messages about cache data that should be considered stale, should be removed from all the caches in the cluster. So for example, if you delete an entry on a database, then the server that does the delete operation will send a message to all other servers to just remove the entry from the cache and consider it stale. And when the client next asks for it, it will try to load it from the database. If it's deleted, it will not find it. If it's just been an update, then it will load the new data from the database and have consistent data. One thing to note here is it's a best effort synchronization or best effort invalidation. Basically, if there is a network error and the message can't be distributed or doesn't reach the server or can't be processed, there is a chance that the other server might have a stale data entry in its own cache. This is also the reason why Alfresco usually does additional staleness checking via their cache keys, for example, including optimistic locking and version IDs in their entities. To define a custom cache, if you were so inclined, there are basically two steps. First, we have to define two string beans, basically the transactional cache as a facade and the actual cache as a string bean implementation. It's pretty straightforward, basically just a copy, paste, and adapt situation, because the properties are always the same. The only thing you would want to adapt are the cache-specific configuration properties that refer to settings you can set in the Alfresco global properties. So this is a very generic pattern, and you could even automate it or simplify it by using, for example, some string bean definition registries, register components that automatically emit these bean definitions, so you don't have to actually to write the XML. So a bean definition registry post-processor interface, for example, from Spring, could be used to generate those Spring definitions on the fly instead of having to write them manually. Cache definition in terms of the configuration properties. This is an excerpt, or basically the types of properties that are supported for configuring caches. The default configurations for Alfresco caches you will find in the caches properties files in the Alfresco repository project, and you can also use the same pattern to configure your own caches. For Alfresco community, basically just the upper half is relevant because this lower half is enterprise only, and specifically the eviction policy has a bit of a limited functionality for community caching. So only the non and LRU types are actually used for community caches. And yeah, you can find out all about the configuration properties and what they mean and what they affect in the documentation. This is the part that's actually very well documented in the Alfresco, on the docs Alfresco page. So it's pretty easy to create new caches if you would like to have custom caches. One question is, what caches actually exist in default Alfresco instance? And interestingly, by default, if you install a base Alfresco community system, not an enterprise system, you have 52 caches by default in Alfresco 5.2. So I hope if Alfresco 6.0 comes out, we don't have 60. And if we ever adopt the versioning policy that Chrome or Firefox has with 42.0, we don't end up with 400 caches or so. It can be hard to find the list of caches that are configured. Basically, you would have to look in the caches property file in the Alfresco repository source code to find the list of caches that are defined. But you can actually also use the support tools add-on that we provide from the Order of the Bee to see the caches and actually see their states in terms of how much entities they contain and what their hit and miss rates are. To actually also find information about what aspects you could tune from a cache. So what is the impact of caches? One of the greatest impacts you can observe when doing a search, for example, against Solar, and this affects specifically the node.anything cache, basically node property cache, node aspects cache, and everything else. because those are the most important caches in the entire system. And just doing an example Solr query, I think it was for about 200 results page. The difference is basically that you can reduce your time of execution about 60 to 70%, just having empty cache and full caches. And this is also done ensuring that the cache on the Solr side was already initialized, so it's not actually just caches on Solr, it's purely caches on the repository side that bring this kind of improvement. Of course, it depends on the amount of data that you're loading. The more data that you don't find in a cache, the less the impact will actually be. So this is for 100% effective cache difference. Also, memory footprint is something to consider, especially for the core caches that Alfresco uses. If you consider that we are using node-ref objects and QNames quite a lot in Alfresco Java code, passing it around for aspects, for property identifiers, and if each of those objects would be separate objects storing the entire namespace URL, for example, it would be quite a waste of memory. Using a core cache like the memory, like the immutable entity shared cache, we can actually reuse the same kind of entities, the same kind of objects multiple times. And basically for every instance of a QName, we save about 350 bytes, which can have a significant impact on the JVM garbage collection pressure and on the heap usage. And the more properties you have, the more aspects you have, the more pronounced this effect will be, obviously. And lastly, for specific use cases on a service level, there can be quite a significant improvements on reusing calculated data. For example, for the user to authority shared cache. Basically, if you're looking to the groups of a single user over a multi-level hierarchy of groups that he can be a member of, and this type of cache helps to basically shortcut the entire execution of the recursive lookup. It can have a significant impact because the group hierarchy can diverge and can be really complex. And this is also usually a reason why people recommend to have not so many layers of groups above a user. But still, this would shortcut it, but if there's any change in the hierarchy, the entire entry for this user has to be cleared from that cache and recalculated, which is the reason why people recommend not having too many groups in the hierarchy. As I said, we can use custom caches. On the DAO layer, it's recommended to stick to the entity lookup cache. And on the other service layers, there's typically a checklist to follow or a questionnaire to follow and to decide if caching is really relevant and really useful for you. One thing also always to consider is what is the cost of missing a cache entry? What is the cost of a lookup? If it's just a couple of milliseconds, then it might not be worth to do in cache and have the memory impact on the system, which can actually introduce garbage collection issues which had seconds of magnitude of side effects. Otherwise, if you have a lookup that is done 1,000 of times within a transaction, then it might be certainly useful to cache the data. Also, what amount of memory are you requiring for your cache data? How large is the entity? Can you optimize it to fit in a smaller footprint if possible? And yeah, what would be the keys that you could use to ensure that your data is consistent, that you avoid stale entries in the database or between the database and the caches? And how do you really realize that data has to be invalidated, has to be removed from the cache? Usually for this use case, I use behaviors or policies or even asynchronous actions to react to changes in the Alfresco system. For example, node property update, and then use that to invalidate my second or third level caches that I have on the business side of things, which is, I think, the most efficient way, and also the way that allows me to be transactionally consistent, because I can have a policy fire on every event, so it's immediately and not asynchronous. And I don't have to fear issues of data staleness. Of course, I can always include version IDs or version keys in my key, like Peter did with his two-way synchronization, for example, between Alfresco instances. So this is also a way to avoid cache issues or consistency issues. What about repository cache tuning? There are a couple of problems that usually happen, and the only thing I think you find about understanding the issue of a cache problem is usually just a one-liner. Okay, you can basically tune anything to your requirement, but no explanation what you can cache optimize to which kind of issue or which kind of requirement. Only a small warning that yes, you can tune anything, but tuning may really destroy the system, basically, may cause other issues, especially out of memory issues. There's only, I think, one recommendation that is available out there. If you have a transaction full message, then you can increase the cache size. but that's about it, I think, in terms of recommendations. So the sources of information are actually important for you to determine what your concrete problems are, and this includes, for example, log files for those kinds of messages, transactional cache is full, monitoring of your JVM heap garbage collection processes, as well as other tooling, your cache configurations, and and tuning guides that are out there. Hopefully qualified tuning guides, so not every tuning guide you find on Stack Overflow might be the one I would recommend to go with. As I said before, there are by default in Alfresco no insights into the state of caches unless you install the Alfresco or the All of the Bee support tools add-on, which reported from the Alfresco support tools add-on and enhanced with additional tools. And in this screenshot is the same screenshot as before. You can actually already see a couple of problems. For example, if you look at the most used caches, nodes shared cache and nodes properties cache, we see extremely high miss rates, extremely high number of evictions, and basically all of the caches are full. So in this case, the performance might suffer because we have a lot of access to data that has to be loaded from the database, and we might also have some kind of round robin where data is loaded into the caches. The next request comes along and because the cache is full, has to remove all data from the cache, load new thing, and if you repeat one request you had in the beginning, then basically you have to reload the data that was just evicted. So it can be a vicious cycle in terms of performance. Transactional update cache is full is, I think, likely the most often seen message or most often asked about question on the community forum, community platform, as well as on Stack Overflow. What is the reason for this kind of message? Basically, within a single transaction, you've either read or modified or deleted too many entities within the transaction, so that a specific size limit has been passed, and Alfresco tries to optimize performance, tries to optimize memory within the transaction, and then says, okay, it's too hard to figure out which data sets to invalidate, and basically ends up invalidating all data in the shared cache, basically flushing the entire cache to zero, which can have serious consequences for your performance. Actually, the check for transactional cache is full is only done on modifying access, so you can actually technically read about 1 million entries per transaction, but if you then update or remove a single entry, then it will trigger the transactional cache is full message and flush your entire caches at the end of the transaction. And it's usually based on the number of entries that you are accessing. Quick and dirty solution, which you always find in the forum and the community platform or on Stack Overflow, just increase configuration for transaction max items. But this configuration is actually in place to limit the amount of memory that a single transaction can take in the Java heap. So it's not really recommended to do this always. The proper solution from my perspective is always to analyze and fix the use case that is triggering this kind of operation, this kind of warning. And one thing is to decrease the size and of scope of specific operations, decrease, for example, batch sizes in a transactional feature or in a job processing. One example would be processing the activity feed from Alfresco to reduce batch size to remove to limit the amount of data that needs to be processed. Also, if you have a custom operation, don't do stuff in an extremely complex recursion. Try to do it in a batch operation. Try to look up via transaction metadata queries instead of iterating over the node service child path, for example, if you have a multi-folder hierarchy that you want to process. I've seen people collect data via recursive algorithm in a single transaction in a system with about 1 million nodes per site, which is, yeah, suicide. Shared cache optimizations. What you can always do, or what you always should strive for, is to optimize the cache so that all of your cache data fits into the old generation of your JVM heap, and also leaves enough room so that the garbage collection doesn't have to run every single iteration. So basically it should fit, I would say, in about 60% of your old generation, so that you don't add pressure to your garbage collection. It also should also support a limit, a certain amount of data entries that you think are necessary to be cached for your use cases to be efficient, for your user accesses to be performant. One thing I've done in the past for a customer is use query logs and access logs to pre-optimize the cache load behavior. For example, have query logs from the last day used as a source of input, source of information for doing batch cron job operations to preload sets of data during the night, so the next day people would likely find the data that's most recent already loaded into caches, especially, for example, for large contract files or for large let's say, case management constraints or constructs. Estimating memory consumption of a shared cache is quite difficult, can be quite difficult, because there's no easy way really to have a unique formula to calculate everything. My experience is that you can use basically this kind of formula to get a rough estimate of your memory consumption, and this could be used to estimate how far you can increase the max items configuration for your shared caches. This so far has been proven by about 2 or 3 major installations with up to 50 million documents and using heap memory analysis. If you want to look at it, these slides will be up after the session. I think they are all already up on the app. Extreme use case would be to really do a custom implementation of a cache. I did this last year since I had a bit of time between leaving my old job and starting new work with customers. And I actually used the Apache Ignite library to do my own custom cache implementation. One advantage that this library provides is that it can store data off heap, so it reduces the pressure on the garbage collection, reduces the amount of time that it takes to do a garbage collection, which could optimize performance in a cluster, for example, and avoid having cluster split issues. And the basic approach is simply to implement the simple cache API, the simple cache interface, and hook that into Alfresco by overriding the cache factory. And then as an optional task, I use the default cache properties to default my configuration and only provide the default the overrides that are necessary to deal with some weird use cases in Alfresco. For example, the immutable singleton caches where actually service instances are stored on not data objects, which can be problematic if it suddenly is serialized and sent somewhere else. So, annoying cache splits in terms of Alfresco. Some caches have a time to live. This can really impact performance quite significantly by removing data too early, especially for the node shared cache, which is used for bulk loading the data on a search. The headcast version is quite obsolete. Actually, 3 minutes, not 2 minutes. So I'm a bit behind the time, unfortunately. Yeah, so the version of Hazecast in Enterprise is obsolete. There have been a lot of improvements in later versions, especially around performance. That did a lot of benchmarks even against Ignite. And there's also even some non-standard caches in Alfresco. So for example, in the node DAO, there's a parent SOC cache, which is not configurable, not conforming to the API, and which is really an internal implementation detail and can't really be optimized out in any way by somebody external to Alfresco. So lastly, Solar caches. This are a lot less slides, so hopefully we have time to finish that within time. So as I said, it's also a tiered layer or multi-layered setup. We have a couple of default caches that are used by Solar in any installation, and we have a couple of caches that Alfresco adds for specifics, for example, handling the ACL checks and the path trees that Alfresco performs. And they can be used in any of those lower tier subqueries in your full query, depending on what your use case is. Cache relevance here as well. Significant differences. It always depends on what type of query you're performing and how large the index is, obviously, how fast your I/O can be. So, for example, in this case, this is a 1,000-fold improvement just for path query if it can be served by a cache instead of having to be loaded from disk and executed live and then stored in a cache. So it can be significant improvements, especially if you have a low I/O system, can be very large. Sorting by score, so by relevance of the search result, can lead to issues where some caches can't be used because they don't carry the score with them and have to be query-specific scoring. But still, the lower level caches will always be reused. It's just the higher level caches that might be skipped in these use cases. So if possible, if you don't have to sort by score, then performance will be even better in most cases. And yeah, in terms of estimating the memory, it's pretty simple because basically each cache stores as much needs as much memory as the amount of documents you have in the index. It doesn't matter the search result, only the amount of documents that have been indexed are relevant. So using that and multiplying it by or dividing it by 8 is enough because it's using a bitmap structure. Understanding Auditorium, basically every time change is made to the index, so if an update happens or a delete happens, data in caches is Auditorium. That means the query that was used to create the cache entry in the first place is rerun, and then the updated data is stored again in the cache. This only happens for a small subset of the entries in each cache by default. So the limits that Alfresco provides by default are quite low, which means that if you have a long time between updates and a lot of people are creating queries and creating cache entries, a lot of them might get lost on a single update, and the performance of the system might have a sudden drop until the users query the system again. So in some cases it might be good to improve, to increase these values. And yeah, one option is also for someone who's doing custom implementation to provide a cache regenerator to modify the behavior of this regeneration. So you can actually reject costly queries to be not regenerated, for example, the wildcard queries or complex path queries, which can take seconds to execute, and reject them or offload them to an asynchronous process to reload the data at a later time, and avoid having a wait time for the first query to actually run after cache update. If you want to look at statistics for Solar caches, this is available by default in the Solar admin UI. I think everyone who's done some Solar optimization or Solar analysis already seen this, so it's nothing new. And in terms of tuning, which is basically the second to last slide, so that Eunice doesn't get nervous, typical focus usually is about optimizing the hit ratio of your cache entries and to limit the warm-up time that is necessary to update the cache entries after change to the index has been made. But in some situations that might not be as easy to find out what the best option is, because through the layering the cache statistics are actually a bit skewed, because if the higher level caches catch the query, you won't see it as a hit entry in the lower tier caches. So there might be some bad data that is actually good because the query is already cached before the cache is used. General priority I would always give to optimizing the I/O caches and the throughput of the I/O system, because if you have a cache hit, the performance penalty that you get then will be directly related to how fast your I/O is. So if you have limited memory, I would always try to move as much memory possible to I/O caches on the file system layer and optimize that before trying to optimize the query caches in Solar. And depending on the situation of the system, there might be different approaches to caching. So if you have a high frequency of updates in the system, it doesn't matter that much how many queries you actually auto-warm, how many entries you auto-warm. You're just focused on about reducing the time it takes to refresh the caches. On the other hand, if you don't have many updates, then it might be useful to increase the number of queries that are cached and carry over a larger number of those cached entries, so people don't see a sudden drop of performance. So, in closing, the art of the cache can be, or the art of the cache as I defined in the beginning, is the understanding of the cache mechanics in Alfresco and applying them to effect. They can be separated in different levels, and I would say everyone who's administering an Alfresco system should have at least a basic level. That means understanding in general how caches on a Solar side, on a repository side behave, how configuration properties can be used to optimize certain aspects of the system, or how much memory, for example, is used for a specific configuration. Then we have the advanced layer or advanced level where people actually start using custom caches in their own custom solution implementation. So, for example, optimizing array lookups in add-on functionality. And then we have basically the rogue layer or the wild layer, basically do anything with caches, replacing complete implementations and ripping out everything that is default at first and replacing it with something better, for example. Yeah. So, and after that, you can go basically wild and do anything with it. So, I'm a bit over time, I think 2 or 3 minutes, but thank you for your attention and your patience.
Thank you, Axel, for this deep insight into Alfresco caches. Yeah, I guess a lot of you should have a few questions, but due to the time limitation, I guess we might be able to only get 1 or 2 of these. So, during the time the next speakers are preparing for their presentations.
So, since this is very interesting and useful, can you make a blog post?
Yeah, I mean, certainly I will have to write a couple of blog posts for this conference, for example, for the hackathon, for other stuff. So I will put it on my queue, but I can't make any commitment in terms of time frame. But I certainly try, and as I discussed with Tristan, I will use the community platform more to share this kind of information afterwards. So hopefully in the next 3 months, just to be safe.
Right? Any other question?
When you're doing your Ignite stuff, what do you mean by weird?
Weird.
caches?
Well, one thing that would be weird is storing services in caches just to make them singletons, which is kind of a weird use case. And then having to deal with all the transitive references that they include. Message bundles, for example, are also stored in caches. I mean, I know why, because the transactional handling in a cluster makes it possible, if you upload a message bundle to the repository data dictionary, to invalidate those message bundles. But it's typically not a place where I would put it, and it can have issues with serialization, especially if there are non-serializable Java objects in that reference chain. And one issue I had with my custom implementation is that basically the entire namespace and dictionary component were serialized and try to be sent to another server, which can be about a couple of dozen megabytes in size. And usually it's not functional afterwards.
All right. Thank you, Axel, again.
Thank you.
And if anyone else has any other question, feel free to find Axel in the hall or wherever you find him, and to ask him more about caches and tuning and other stuff as well.
Anything that goes into much detail of Fresco, yeah, if you like.